A very simple application of machine learning is as follows. You can actually see how machine learning happens through this very small demonstration here. All of you can see this one. So see, this is the input and this is the output. And what we do in machine learning is we give the machine lots of input-output combinations, input-output examples. So we give the machine lots of input-output combinations, X, Y, X, Y, X, Y. So we show the machine a lot of data. And the machine learns the patterns. The machine learns the rules from the data. That's the way how we look at machine learning. So we give the machine lots and lots of data, and the machine learns the patterns. The machine learns the rules from the data. That's how we generally look at the term machine learning. That's how we look at it overall, what machine learning is all about. So give the machine lots and lots of data, lots and lots of historical data, XY combinations, input output combinations, you show it, uh, and the machine will learn the rules from the data. So if you see the screen here, 1, 2, 3, 4, 5, 6, 7, 8. So we are giving the machine lots of historical data, how the inputs and outputs look like. So how the inputs and outputs look like. 1, 2, 3, 4, 5, 6, 7, 8. So the machine will learn the patterns, or it will learn the rules from the historical data, and it will learn the rule as y equal to x plus 1. So what is the rule the model will learn? It will learn the rule y equal to x plus 1 based on the historical data. And based on the rule it has learned, next time I give it an input 9, it will predict an output 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So it will learn the uh, rules from the historical data. Okay, it will learn the rules, which is nothing but a function, or it's a model. So if we build a model from the historical data. Whatever historical input output combinations we have, we learn the rules from that. And next time we have a new input 9, the model will predict an output 10. So this is what will happen based on the historical data. Okay, and then there are two very important terms that we use in machine learning. And as again, one is called model training, which is called dot fit. Right, so you give the machine the historical data and you train the model. So when we say training the model, what it means is you have the historical data, and we will use some kind of algorithm. We will do a dot fit, and we will build a model. This is called model training. From the historical data, do a training. That means do a dot fit and build a model. This is the part where you learn the rules. And I hope everybody understands the difference. So in rule-based AI, this is something we were hard coding. We were explicitly telling the machine, if the input is this, the output will be this. We humans, we had to study the characteristics of the system. That is what software developers do, right? When we collect requirements, that's what we do. We go through the system requirements, we understand each and every aspect of what is to be done. And we write rules, we write the program, we write the code in whatever language we have to, right? That's what you do. When you create a website, you are actually collecting the requirements from the client, every single aspect of it, what the way the text box will be, what the color will be, and that is what you're going ahead and programming. You're coding, you're hard coding it. So every single aspect of traditional software development is hard coded. But if you look at machine learning, we are not hard coding this rule. This rule is completely learned from the historical data. 1, 2, 3, 4, 5, 6, 7, 8. Give the machine lots and lots of historical data, use an algorithm, and based on that, we will end up building a model. The model is nothing but the rules or some kind of a mathematical function. This is what we call model training, and this is also done using some kind of a fit. It's also called fitting. There are a couple of interchangeable terms that we use. And if you see, there are three very important terminologies that we used here. One is the data. This is the training data. There is an algorithm. We are using an algorithm to train on the data, and in the process, we are building a model. So there is data, there is algorithm, and there is model. So dot fit, model training, and then once we have trained the model, once we understood the patterns, given a new value of x, we will predict what is the corresponding value of y. That is what we call dot predict. So this is how the entire workflow typically happens. And if you just to summarize, if you see, this is what we are doing. We take some data. This is what we do in machine learning. We take some data, we give the machine lots of input-output combinations, and the machine learns the patterns using different algorithms. So if you look at the traditional machine learning field, there are different algorithms that exist in machine learning. So once you give your input-output combinations, your XY patterns, there are different algorithms that are there, like logistic regression, decision trees, random forests. Many algorithms are there, and those algorithms are used to learn the patterns from the data. Those algorithms are used to learn the rules, learn the equation And based on that, we end up building a model. We end up building the function. And once we have the mathematical function, using that we can predict, given any new x, we can predict what is the y. This is the workflow. Okay, so this is how machine learning is different from the traditional rule-based AI, and it is dynamic and it is error-prone. As you can see, it's not hard-coded. So the rules are not exactly static. The rules are dynamic because it is learned from the data. And as you can imagine, if the data changes, if the underlying data changes, let's say whatever data I have today, like these X, Y combinations, tomorrow I would have generated some new data. Day after tomorrow, I would have got some new data. So every day the data is changing. And as the data is changing, similarly, the rules or the patterns are also changing. So that is why we say in machine learning, the rules that are learned are dynamic. The logic that is learned is dynamic. Whereas in traditional rule-based intelligence, the rules are static. Unless we change it, the code will not be modified. But here, the code is kind of modified automatically because the machine is constantly figuring out the rules from the incrementally generated data. Of course, that's model retraining that has to be done. And to extend the conversation, there is something called deep learning. Going back to our slides, if you remember, there's something called deep learning, and that is typically a subset of machine learning. So we talked about AI, we talked about rule-based intelligence. That's a way of doing AI, and we can also design intelligent systems using machine learning. And a subset of machine learning is deep learning. There's a term DL I have consistently used. So the idea is very similar. The idea of DL is again very, very similar. Here also we have the data. We give the machine lots and lots of historical data. The only difference is deep learning has specific algorithms. There are special algorithms that are used to learn the patterns, but the end result is the same. The end result is we end up getting some kind of a rule, model, or some kind of a mathematical function that associates the relationship between X and Y. Okay, that is giving us some kind of an association between the input and the output. So the idea of deep learning is exactly the same. Here also, we give the machine lots and lots of data. The machine uses deep learning algorithms this time, which are actually neural networks. This is neural networks, and those kinds of things are used to learn the patterns, learn the association between X and Y, and the end result is some kind of a deep learning model, rules, or a mathematical function. So the end result is again some kind of an equation, or it may be an equation form, may not be an equation form, but this is the way we generally understand the terms. Okay, so then you might be asking a question that, okay, then why do we use deep learning if we already have machine learning, which is learning the rules? Then why is deep learning used? So deep learning is generally used in cases where we have unstructured data. So deep learning works very well, and deep learning scales very well, especially for unstructured data. So if we have images, audio, video, or text kind of data, then deep learning scales very well. Okay, because the patterns are more complex. I was talking about Google Photos, like if you remember, this was the example that I was showing you. So if you think about this kind of a system, if you think about this kind of a system, this is actually again working completely on the basis of deep learning. If you think for a minute, how did Google design it? Because right now what we are seeing is prediction. Right now what we are seeing is model inference, model prediction. So given a picture, we are trying to predict, okay, is it a mountain? Is it an elephant? That's what we are doing, right? When we type something here, this is like model.predict. But the model has already been trained. Google Photos already has a model that has been trained behind the scenes. Now all that is happening is next time I click a picture, next time I take a photo, Google is simply going ahead and predicting that, okay, given this new image, what is it called? Is it a mountain? Is it an elephant? Is it this? Is it that? That is all that is happening right now. So Google has spent a lot of time and effort and resources to train this model first. They would have collected lots and lots of sample data. So even before we come to this step, Google would have collected lots and lots of data. So they would have trained the machine with lots and lots of historical image data, and and these are pictures like, these are like, okay, pictures like this are called mountains. This is not from my photos. Google will have their own repository of images, and where they will train the machine very similarly like how we looked at here. So they will train the machine this way. They will say, okay, these are images which correspond to mountains. These are images which correspond to elephants, and these are pictures which correspond to trees. So the X will be a picture and the Y will be a label. So you will show the machine lots and lots of images, right? So you show the picture, lots of pictures of mountains, and say it's a mountain. You'll show the machine lots of pictures of elephants, and you will say it's an elephant. And you will show the machine lots of pictures of trees, and you will tell the machine that, you know what is called a tree. This is how you're teaching the machine. You're providing the input output combinations, and the machine is figuring out some association, and it is figuring out some rules based on the data that you're providing. And then there are other ways to form those rules as well. Those are technical aspects we are not getting into. There are neural networks that are used for it. But the end result is there is some kind of an association. There's some kind of an equation we learn. There's some kind of an equation between the label and the pixels of the image that we are able to kind of learn at the end result. So the machine is able to figure it out. Not that we are hard coding, but based on the data, the machine figures out some association. And next time I give it a new image, the model predicts that that new picture is an elephant or a mountain or a tree, whatever that is. And that's the way how we can think of traditional machine learning. Okay, I hope everybody's getting a sense of traditionally what machine learning is basically all about. So that's exactly what's happening here also. If you think about it, that's exactly what's going on here as well, where we look at a picture, and next time you click a photo and you look at an image, Google is also trying to effectively predict what that picture is called. Is it a mountain? Is it a tree? Is it a photo? Because they already have a model that is built. And that model is also constantly evolving. Not every day, but Google will have their own retraining frequency. Every day, their mistakes will be made, and that is the other important thing about machine learning. Sometimes machine learning can be prone to mistakes. It is not guaranteed to be always 100% accurate. Now here it is working fine, but there are a lot of cases where the answers may not be fine. Okay, for example, Google has made a lot of embarrassing mistakes in the past. Okay, and if you see, uh, it has actually a lot of times it has actually made some mistakes. Okay, it actually even recognized people as gorillas at times. Okay, by mistake. Okay, so there was a very infamous incident that happened where where Google uh, misclassified misclassified a black person to be a gorilla. Okay, so this happened some time back where uh, you know uh, let me bring it up. Let me quickly bring it up. Excuse me. So this was a real incident that actually happened. You can see the bottom part here actually. So you can see the bottom part of the image here where this is a real story where Google misclassified the black person to be a gorilla actually. So what I'm getting at is machine learning is not always 100% correct, not always 100% accurate. And if you think about the reason why this happened is because the machine was trained in a very biased manner. So the data that is taken is very, very important. Whenever you train these kinds of systems, it is very important to collect the right kind of data. Okay, so maybe here one of the things that happened was while training this kind of a system, the machine was shown lots and lots of images of black, uh, animals, and the machine was shown lots and lots of examples of white humans. Okay, because Google is an American company. I'm just giving an example. It doesn't have to be that way. And this was long back. This was more than 10 years back that this happened. So maybe the sample set of humans that they had were all whites, and the sample set of gorillas they had was all black, because I don't think gorillas come in any other color. So it's like saying that, okay, anything which is black is a gorilla, and anything which is white is a human. So your data itself is like that. So next time a black human stands and takes a selfie, Google says you're a gorilla. Okay, because it is just doing classification that way based on what it has been trained on. Okay, so this is the other aspect of machine learning, that oftentimes machines can end up making mistakes, right? And you can see there are some biases. There are some inherent biases that constantly happen, right? For example, this one. So Google understands that whenever you wear this kind of a hat, it is related to graduation. I think even as humans, we kind of we kind of have a similar kind of association in our heads, because we have also seen similar kinds of graduation photos in movies, in TV serials, and all that, right? So that's how we humans learn the same way. If you look at humans, we also learn the same way. We learn from examples. See, it may not be graduation, it may be something else. But based on our association, based on our understanding of how things are, it seems to be a graduation. So that's why when we look at this image, we say it's a graduation based on how we have been trained, based on our data. That's the way to look at it. Okay. So this is just to introduce the idea of what is machine learning at a very, very conceptual level. And just a final example, all of you can see, this is what I was talking about, how humans learn and how kids learn. Okay, humans learn the exact same way. When we were all young, when we were all attending school for the first time, we were all taught what fruits are, what the different types of fruits are, and how fruits look like. Okay, so somebody had to tell us that, okay, these are how apples look like, these are how mangoes look like, these are how guavas look like. Somebody has to teach us, right? And this is exactly how the data looks like. So somebody has to show us lots and lots of examples of fruits and say, okay, you know what? Fruits like this are called apples. Fruits like this are called guavas. Fruits like this are called apples. And fruits like this are called guavas. So somebody has to show the fruit and then say it's called an apple. And that is how the kid learns. That is how the child uh, forms an association between the picture, the pixels in the picture, and the label, what the label is actually called. And that's the way how real world machine learning, and that's how humans also learn in some way. So humans learn the same way, uh, machines learn from lots and lots of example data. Okay, so if you are not taught about some kind of fruit, you will never learn. If I show you lots of pictures of apples, if I show you lots of pictures of guavas, you will learn very well. But if I don't teach you what is a jackfruit, or if I don't teach you what is a dragon fruit, I don't think in very early age people talk about dragon fruits. It's only like first 2 days in school, maybe the teacher will teach you about apples and guavas. So the kid will learn that. The kid will learn what is an apple and what is a guava. But the kid may not know what is a dragon fruit, and the kid may not know what is a jackfruit. So that's the way to look at it. So the machine is only as good as the kind of data that you have used to train it. Okay. All right. I have another very nice animation and a very small demonstration that I want to do with all of you. This is to further give you a very nice understanding of how machine learning actually happens, how machine learning actually works behind the scenes. So there is a website called Teachable Machines. I'll take you there, and I wanted to demo this machine learning for all of you. It's a very nice animation. The Teachable Machines is a very nice animation. So there it is, and you can actually see the entire machine learning piece in action, pretty much whatever we talked about. So we can take a small image project, and what I will do in this is I will take some examples right now. So let me just create two classes. So I will create a class which corresponds to a, let's say, a remote. Okay, so I'll hold up a remote, and in the other hand, I'll hold up something. What do I hold? Let's say I hold up a water bottle. Okay, a bottle. Okay, so let me take those two objects here. Then, and what I will do is I'll try to demo this to you real time, exactly what is happening. Okay, so we all understood rule-based AI. We all understood in rule-based AI, we are hard coding the rules. Okay, we are studying the system, we are hard coding the rules, and you will see in machine learning how the machine is learning the rules. Here, you're not hard coding; you're simply showing the machine lots of examples. Okay, so let me turn on my webcam and let me quickly show you how this looks like. So we have got lots of. This is the remote I'm holding right now. So this is how the data is collected. Can you see? See how I collect lots and lots of examples of remotes. I'll quite literally rotate it. Like see. And it's very important to show the machine different examples, like the remote can look like this, the remote can look like this. It's important to hide the name Samsung, let's say. It doesn't have to be Samsung. So I don't want the machine to associate Samsung with the remote. So you try to show as much of variety. It can be a very close-up view of the remote. See, like this. Even if I show it something like this, it will know it's a remote. Even if it sees this, it knows it's a remote, right? Even if I show the back side, very, very zoomed view, it should know it's a remote. So see, there are so many different ways remote can look like. And I've already shown 393 samples by now. And similarly, I will show the machine lots and lots of examples of how water bottles look like, right? I'll show the machine lots and lots of examples of how water bottles look like. You can see. So the bottle can look like this. The bottle can look like this. The bottle can look like this. There's so many different ways bottles can look like. So I have to show a zoomed in view, right? Maybe just a cap. Maybe this. Okay, you can see how bottles look like. Okay, you can see this. So 390 examples, approximately that. This is a very balanced kind of example I've taken. So there are around 390 examples of uh, remotes I've shown, and there are around 390 examples of bottles I've shown, all very varied pictures. And this is the very important criteria in machine learning. You have to ensure that the images are very varied. There are different varieties of remotes, and there are different varieties of bottles. The pictures are very varied. That's what we have here. And now what we will do is we will go and train the model. That's it. This is the part where the machine is learning the associations of the from the inputs to the outputs. That is what is happening right now. So it is building a model, and you can see it takes a while to train. And after that, we can do predictions. We can actually do the predictions. So next time I show it any new picture, the model will be able to predict what is that picture. So this is machine learning. This is effectively how things were happening in traditional machine learning terms. Okay, and now you can see that this is I can hold up a picture of a remote. This is what a bottle looks like. You can see no matter how I hold it, the machine still knows it's the bottle, and I can hold up a remote, and the machine knows it's a remote. See how prediction and inference is happening. Even if I do it this way, the machine understands and it's learned pretty well it's a remote. Even if I give a zoomed in view, it knows it's a remote. If I show it just a picture of the cap, see, it knows it's the bottle. See how beautifully it has learned it. This is what machine learning is all about.